And yes. And there are a few things that Kelvin wanted us to address for this PSet discussion. Um,
Mm-hmm.
and we can talk about it. But right off the bat, is there anything that people feel like um, is just easy now that we can ignore? Go ahead.
What I wanted to discuss was the discontinuity part.
The first problem?
Not, but the general method for finding nearly all type of functions.
Okay. Okay. That's a good one. Yeah.
And other all were doable, and I had done them. And I had also done the first one,
Mm-hmm.
but I wanted to learn about some more functions for discontinuity type and
I see.
finding points for them.
Right. I'm trying to right. This is Calvin's solution. Yeah. So how does everyone feel about starting from the first question itself, discontinuity? Can you do that? So the first problem asks you to find at what points your following functions are going to stop being discontinuous. Right. Another question that I could have asked is like, what's the nature of discontinuity? Is it like the things we saw last time? Is it jumping discontinuity, or is it like the other ones? Um, Here you just need to show at what points your limits do not exist, essentially, right? And it's pretty straightforward to see how that happens. Um,
I think there's some, at least for the first one, I think we all agree that the function is continuous everywhere. But for the second problem, my answer was that it's only continuous when x is greater than 0.
mm-hmm,
So from 0 to infinity, 0 not included. Um, but I think some other problem set solutions I've just looked at, I think some people said that it's discontinuous at x equals 0, and it's a removable discontinuity. So yeah, maybe we can, since there's like some different solutions, maybe we could talk about the second
mm-hmm.
question for this. Yeah.
Okay. So the second question is 1 over square root of x, and OJ's answer is that this function is continuous for all x like greater than 0, not including 0, and all the way till infinity. and again continuing, x equals to 0 does not work due to division by 0, of course, and x less than 0 is undefined for square root of x because it's going to be imaginary. So that's Hoji's answer. Siddharth. He also writes the same. At x equals to 0, you have the function is undefined, and the limit goes to positive infinity, and the negative side is like not. It can't exist, right?
Mm-hmm.
So that's correct. Michael. Right. So it's the same thing.
Is that wrong then?
Which one?
My answer.
No, you said it is not defined at 0, x equals to 0, but you didn't say like the limit of it, which is like infinity. But again, it was not asked in the question, so.
Okay.
Yeah. If we look at Kelvin's solution, he gives the same thing. Discontinuity occurs at x equals to 0. He doesn't quite explain why. No, I think he does. He just missed saying that like it's undefined or so. Yeah, the function is discontinuous at x equals to 0. For the first one though, it's pretty much the same. You have to, this is Michael's solution. He solves the quadratic, and he describes it in terms of the discriminant being positive, negative, or 0, which leads to real complex solutions, right?
Okay, that's what I did.
Right, yeah. Hoji didn't do that. Hoji just said.
It seems I was disconnected.
Sorry?
I think I was disconnected for.
Oh, I see.
Right.
Yeah, can you see the screen now?
Yes, I can see.
Okay. Hoji does that, but without like going for the discriminant route, we just say that like as x squared plus 1 is never going to be 0, because x squared is going to be positive always, and plus 1 is always going to be positive. So it's going to be continuous everywhere. I don't think that's a good enough reasoning. Oh, I think it is, because you're going from minus infinity to plus infinity. So, yes, it works. But I think I like the Michael's answer more of going the quadratic way. It kind of makes more sense.
Sounds good. So for B, I guess my question, Michael wrote, it is a non-removable discontinuity.
Right.
But is that? I guess I thought that it wasn't. It's discontinuous, but I guess it's not one of the discontinuity we've seen. It's just that this function is just defined for positive x's in the real.
What I thought was that can have a removable discontinuity. That's the circle, or you can have like an asymptote.
That's like the non-removable is correct, and I think the non-removable is only if you cannot factor it out, and I think you cannot really do that here, so that's why I wrote non-removable discontinuity. But if that's wrong, then is this correct?
Yeah, the answer is correct. It's just that the non-removable discontinuity part is
because it is not a circle here. You don't have a hole. I think you have just.
Yeah, so the thing is, like, at x equals to 0, your function is undefined, so you have a hole in the graph, and that is by definition the non-removable discontinuity. It's just that we didn't see it in our examples lectures. So
okay.
The removable discontinuity is when, like, you can remove that particular point, for example, x equals to 0, and the rest of the function.
Oh yeah. Oh, you said not removable. Okay. Sorry, Michael, I misread it. I'm good. Sorry, I had to just light bulb moment.
You got it wrong. That can be. I just thought that it was like you have to can factor it out, and if you have like in the denominator and the denominator, if you have it both there, then you can remove it, and then it's removable, and then the other I think I thought was the non-removable. So I thought that this non-removable was always an asymptote, but not like a hole. But I think I got it wrong.
Siddharth doesn't exactly say the reason why this is undefined at x equals to 0. You do see that, like, limit of this as x approaches positive 0 is positive infinity. But why is x equals to 0 undefined?
Means when we will take the square root of 0, it will is 0.
Right,
Then
that's
it will
just
be undefined.
right. You just have to. That's the whole answer. Yeah.
So do we have to usually mention?
Yeah, like if you're like I don't know, giving an Indian exam, you're not going to get marks if you don't write that. Okay.
I will write next time.
Yeah, that's problem 2 of part 2 of problem 1. Then problem 2 is evaluating the limits. You have to evaluate the following limits, as we've seen before. I should have mentioned this in a footnote or something about, like, how you just use the things we have seen, like the limit of the sin x over x or other things that we saw in the last lecture, and use them to get the limits of this one, but it doesn't matter. So this is Jose answer. So the left-hand limit doesn't exist because 1 over root x is undefined here. Then for the right-hand limit, you have 0. Okay. That's correct. Siddharth does the same thing. Yeah, he just doesn't mention about the left-hand limit, but that's That's okay, I guess. Michael uses the L'Hopital rule. It's okay, but the problem is that, L'Hopital rule is like not something we have learned, and it's going to be like
Okay.
way late in the class. So,
Okay, sorry.
right, yeah.
Okay, then I would have to do like split it up and see from I think minus infinity to 0, plus infinity to 0, and I think from minus infinity to 0 it's undefined, as we already heard. So you have to like look at it from the other side, and then you get I think 0.
Right, yeah. So you have to like break this down into elementary functions that we have seen, sin x over x, dx squared over x, then find the limits easily, and get the answer, yeah.
Yeah, sorry, I think I got it wrong then.
Yeah, like the limits are correct, of course. Like L'Hopital rule is not going to give you wrong answers. It's just that the
Yeah, but it was not the assignment,
right,
so
right.
yeah.
Those were the limits question. The third question is about showing that this curve. Okay, so this was a typo. Let me fix it right now. Okay. So you have this function, this curve, and you have to show that this curve has no tangent line with slope 4, right?
Mm-hmm.
And I might have mentioned also that draw the graph, but you don't really need to draw the graph. You can just have this. You calculate the derivative. The derivative is precisely this. You equate that to 4 and find the value of x. Now you realize that it is not solvable in real numbers, so your flow doesn't exist. Yep, basically that. Yep. Then you have to differentiate these functions. Pretty easy functions. But let's see. So the first one is root 2 minus 1 over root 2. So you have to find d over dt of that. So what you do is you first apply the sum rule, right? Taking the derivative of this one and then this one. And for the second term, you have to apply the quotient rule. Yep, this looks like a very elegant solution, Jose. Yeah.
Yeah, I was trying like different methods just so I can see like kind of get a sense of what might be like easier to use next time.
Yeah, we haven't seen chain rule yet, but yeah, if we got
okay.
right, like if you watched lecture 4 already, then you
Okay, yeah, yeah, sorry, yeah, the lectures start to blend in a little bit.
know. The product rule method is also interesting. You take u equals to t over t of 1 over 2, v is 1 minus t minus 1, calculate u prime, v prime, and you use that vu v prime is this, um, so you calculate df dt. This is very nice. Like this is a very mathematically formal way of writing it. Like um, instead of just calculating like dy over dt or something. Mm-hmm. Right. Yeah, that's the answer. Yeah, I just need to replace this x with p. I think you messed it up with the variables, but yeah.
Okay.
The second one is x squared minus 2 root x over x, which is also a pretty easy one. You start with the the quotient rule, and then by the sum rule, and then you'll be done. So yeah, yeah, yep. Method one is quotient rule. Or you can do simplification first and then do that and use the chain rule. This is amazing. I'm afraid if Michael's answer. Oh yeah, it's the same thing. It's just this simplifies to 1 plus
Yeah.
x to the
One
yeah. And the last one is root x times x minus 1, which is the easiest one, I guess. Right. Okay. Solutions look all good.
definitely different answers.
Wait.
So 3x over. So Sudhar's answer is 3 halves times x to the 1 half minus. I think Sudhar's and I have the same answer.
Wait. Which one you're talking difference?
I think this one this one has a x to the 3 halves, which I don't.
Yeah. Wait. Right. Yeah.
Yeah, so Sudhar's and I both have x to the 1 half for the first term, but the first term here is 1 half x to the 3 halves.
Is there something wrong?
I think it's in the second line, y prime equals 1 half. I think it's supposed to be x to the negative 1 half here. Because if you take the derivative of square root of x, then the 1 half will come out, and then but power should be x to the negative 1/2.
Yeah.
Oh, okay.
Well, got it. That the two
So,
should, that the two should come in the denominator, but it seems I have not done that while differentiating, right?
Yours, I think you did it right. Like you simplified it first. Like you multiplied out,
Right.
right? Yeah.
yeah, I think I did it wrong. I think I miscalculated something there.
Yeah, the second step here.
Yeah. Yeah. But I think otherwise is right.
I'm usually bad at like calculating, so that's why I'm here. Try it again.
Yeah. Yeah. That's why I try to also like do it in different methods so I can check my answer. If I get it like the same answer for 3 methods, I guess I'm like pretty sure like I got it wrong or I got it right. Yeah. Otherwise, I guess I got it wrong 3 times, which is
So is it possible to just share this? I mean, the solutions are at the GitHub, right?
Yep, the solutions in
So we can just look at them, right?
Yep, we can.
Okay, so great, thanks.
Yeah, I just pushed everything to the GitHub right now. I'm trying to look at
Kelvin.
that looks okay. Right, yeah, that's just 3/2 times root x minus 1/2. Yeah.
Yes. Yeah. I think for the last question we had the same answer.
Yep, yep.
Yeah.
Let's see, what else does he ask? So he says for the question about finding the discontinuity, what are the steps you have to write down? Okay, the way I've written it, like how is there like more formal way to write it? So I'll just add that the more formal way is just like finding the limits uh, where it is undefined, and saying like why it's undefined, and also like what kind of discontinuity you have, removable or unremovable or other kinds. That's probably that. There's nothing much to it. And regarding the finding derivatives questions, it looks all good to me. Yeah. Let me open this thing. So for the fourth question, yes, 1/√2, 1/2. That's what we got, I guess. Yep, that's correct. And for the other one, yeah, this is also Wait. I think he did it correct, but he, for some reason, erased it. Should be 1 plus 1 over root x cubed, but he scribbled the 1 plus for some reason. But yeah, that's about it. Yeah, this PSet, the goal of this PSet was just to, like, make sure we don't mess up the upcoming PSets, to have just something to do for this week and to practice this kind of computation for sure. So from next week, we're going to do the original PSets of the course material themselves, which would be harder than the PSets we have for sure. So yeah, that's about it.
Yeah. So I was looking at the original PSet. Seems like there's part 1 and part 2.
Right.
There's part 1 consists of, so we will do. So I guess part 1 is coming from the textbook mostly,
Yep.
and part 2 is the questions that it is written
Right.
down here. Okay. Oh, quite long.
Yeah, the
That's
part
okay.
the part 1 questions are often very easy, mostly just computation.
Okay.
Part 2 is where you'll do the real job. So I would recommend focusing most of your time at part 2, but if you find there are the things that you don't understand and you need some practice, do problems from part 1.
Sounds good.
Yep, and I believe the book is something that everyone has, the George Simmons's book, Calculus with Analytic Geometry.
Yep.
Okay, so tomorrow then we're going to meet for lecture 4, right?
Yes.
Yeah, so lecture 4, lecture 5, on the day of lecture 5, I'm going to post the PSet 1, and that'll be due next Saturday. So.
And is that PSet 1 will be the same as this that you were just on, or would it be
Yeah.
your own PSet?
It will be that. I don't think PSet 1 needs any changes, but maybe the further PSets, if I think there's something to change, I will.
Okay.
Yeah, this one is going to be exactly the same. But I'll
Great.
kind of like announce it, post it time so that the deadlines are clear.
Sounds good.
Okay then, have a great day everyone, have a great weekend, and we'll meet tomorrow at the same time.
See you too.
Okay, see you.
Thank you.
Thank you.